Okay, so here is yet another video of help with word problems using calculus and derivatives and optimization. And we're going to do 4 questions that I've assigned my students. The first one refers to an example we did in class, but we change one of the numbers. So I'll go over the example again. It's one where a cable television company is laying cable in an area that has underground utilities, so the cable needs to go underground. 2 subdivisions are on opposite sides of a creek, which is 100 meters wide. The company has to connect the points P and Q, which you'll see when I move this up. So it has to move from P to Q, and with that cable, where Q is on the north bank and it's 1,200 meters east of P, if it costs $40 to lay cable underground and $120 to lay it underwater, what's the least expensive way to do this? So clearly one of the options could be to go straight across the river underwater and then straight down, and you could work out a cost. And then if you were to look, there's some distance that you could, or the last option could be to go all the way underwater. So one of those has a certain cost associated with it, the other has a different cost, and you're looking for what combination of how far downriver and how far underground is going to give you the least cost possible. So the way we'll work that out is, of course, using calculus and use derivatives to get that done. So we don't know the distance. I'll label it x, is the distance downriver from P, or not downriver, but towards Q from P. And if the entire distance is 1,200, then the distance that is outside here would be 1,200 minus x. So this path that you come over is going to be the hypotenuse of this triangle, and this distance, using Pythagoras theorem, you are going to have the square root of 100 squared and x squared. Okay, d squared is 100 squared plus x squared. So this path from P over would be square root of 10,000 plus x squared, and the path downriver is 1,200 minus x. And the cost associated with this section is $120 per meter, and the cost with that section is $40 per meter. So my total cost function is going to be $120 per square root of 10,000 plus x squared, and the cost of $40 per 1,200 minus x as that distance. So that is my total cost formula. I can work out the derivative of this and set it equal to 0 to find the maximum point. Those are our steps that we follow for finding max and min. Okay, so this is really 10,000 plus x squared to the 1/2 power. That's what the square root means. And this is really 48,000 minus 40x. I'll just rewrite that a little bit simpler. Now to take the derivative c prime, I'm going to use chain rule in the first term. I'm going to leave the 120 where it is. I'm going to bring the 1/2 power down. Chain rule says I leave this bracket the same, but I subtract 1 from the power, so it becomes minus 1/2. But then you need to take the derivative of what's inside that bracket, which is 2x. So that is the derivative of the first term. The derivative of 48,000 is 0, and the derivative of negative 40x is minus 40. Okay, so that is what our derivative is. If I combine 120 and 1/2, that makes 60. 60 and 2x makes 120x. This is a negative exponent, so it's in the denominator. It's a fraction, so it's a square root, and you have 10,000 plus x squared, and here you just have minus 40. Alrighty, so if that is my derivative and it equals 0 to find a max or a min point, we'll take this 40 to the other side and make it a positive 40. And then this is gone. We're trying to solve for x, so we'll bring the radical up. 40 square root of 10,000 plus x squared equals 120x. We're about to square both sides to get rid of the radical, so let's reduce this. 40 goes into 123 times. So now you just have the radical equals 3x. Now if I square both sides of the equation, you are left with 10,000 plus x squared here. The root's gone, and then you get 9x squared there. Take the x the other side. 8x squared equals 10,000. You're now solving. It is 10,000 over 8, which is 5,000 over 4, which is 2,500 over 2, which is 1,250, is equal to x squared. We need to divide by 8. You need to take the square root of that to solve for x. Square root of 1,250. Well, 1,250 is 625 times 2. Square root of 625 is 25. So that answer is 25 root 2. Technically, it's plus or minus ever since we took the square root, but it does not make sense to have an x that's negative in this scenario. So your x is 25 root 2. That is how far downriver that you go, so that the other section is 1,200 minus x. So 1,200 minus 25 root 2 is the length of the cable for the other section. So you've got your solutions and you've got your dimensions. All right, let's take a look at the second example. This one you have a Norman-shaped window, which is really just a rectangular section and a semicircle on top. If the perimeter of the window is 8 meters, what width will allow the most light to enter? So you're given a perimeter in this question, and if you want the most light to enter, I think you want the maximum area. You're dealing with the area of this figure and the perimeter of this figure. In the example from our textbook, they label 2x for you. They call that the base of the window. If you might have just called it x, you get slightly different work through, but we'll stick with the 2x because that's what the book suggests. So if 2x is the width of the base, then I maintain that x is the radius because it's half of that semicircular base. So this radius that you see is really just x. And so you are going to have an area of your circle on top, the semicircle. You've got that area, and you've got an area of the rectangular section in each part. So the area of the top part is just half of a circle. And the area of the bottom part is going to be base times height. 2x, and I'm not sure what we'll call it. So we'll call the height y for this window. So my total area would be A1 and A2 added up. But I see, so it would be pi x squared over 2 and 2xy. But I see two variables here. I don't want to take the derivative of that because we have this variable y that we might be able to get rid of. So as usual, you have two equations. Those two equations you can use to get rid of a variable. We see perimeter equals 8 meters. We're going to be able to use that information. So the perimeter of this window is the semicircular section, which is half the circumference. Half the circumference is 2 pi radius, so half of the circle, and the two y sections and that 2x section. So on my picture, the perimeter is the 2 y's. So there's 2y, there's 2x, and then this semicircle. half of the circle. Half of this circle is hidden here. The other half is on top. So half of that circle would be the half of 2 pi r. And radius is x, so half of 2 pi x. That perimeter equals 8. So I see a formula here that says that pi x plus 2y plus 2x equals 8. Alrighty, I can use this equation. Let's solve this for y. 2y equals 8, subtract 2x, subtract pi x, and then we'll divide everything by 2. 4 minus x minus pi x over 2. I'm going to take that y value and plug it in right there. So my area is pi x squared over 2 plus 2x times 4 subtract x subtract pi x over 2. I'll simplify this down before I take a derivative. I'll leave the pi x squared over 2 alone for the time being. 2x is going to multiply in on all 3 terms. That will leave me 8x. That'll leave me minus 2x squared. And that'll leave me minus pi x squared because the 2 and the 2 in the bottom will cancel. All right, so I am seeing, no, let's just go ahead. Let's not simplify. Let's just take the derivatives. The derivatives are easy now. We'll simplify it later. So the derivative of each term, take the 2 down. So you get 2 pi x over 2, which cancels. The derivative of 8x is just 8. The derivative of minus 2x squared is minus 4x. The derivative of minus pi x squared is minus 2 pi x. So I have a derivative. You now want to set that equal to 0 and solve for x. To do that, I'm going to get anything that's not x on the other side. So here I have pi x minus 4x minus 2 pi x equals negative 8. Common factor the x out. Pi minus 4 minus 2 pi equals negative 8. Pi minus 2 pi is negative pi. And so solving, you get negative 8 over negative pi minus 4. Let's common factor those negatives out of here. 8 over pi plus 4. So that is what x would be. The width, if you recall, the width of that window was 2x. So I think you are going to get twice of 8 over pi plus 4. The width of the window is 16 over pi plus 4. That's the width of this Norman window needed. Okay, so there's 2 examples done. Let's take a look at the third one that we had. And this is one that was fun to do. You have a boat leaving a dock at noon, and it's heading west at 25 kilometers an hour. Then you have another boat heading north at 20 kilometers an hour, and it reaches the same dock at 1 p.m., 1 hour later. When were the boats closest to each other? So when you start, I have boat A sitting at the dock on the bay, and it is going to travel west at 25 kilometers per hour. Boat B was south of there because it's going to travel north at 20 kilometers per hour, and it is going to, if it reaches the dock in an hour, it must have been 20 kilometers away. So at the beginning, this is 20 kilometers away. So we know the distance at one point. They're 20 kilometers apart. After that, things get a bit squirrely because every minute that travels by, this one's going faster, That one's a bit slower, and the distance between them would have to be calculated using the sides of a triangle. And when A moves further and B moves further, you would have a different triangle. And really what you're trying to find at this point is a whole bunch of distances that are hypotenuses of triangles. So rather than draw a whole bunch of these, we're just going to move this stuff out of the way and set it up with some variables instead. All right, so what we know here, this distance is going to be 20 kilometers. Subtract whatever distance the boat travels, and it's traveling 20 kilometers per hour for a certain amount of time t. So its distance that it travels is going to be 20t, speed times time. Okay, speed times the time of the that it travels. So 20 kilometers subtract 20t is going to be the distance of this part of the triangle right here. For boat A traveling that away, his distance traveled is still speed times time, but it's his speed times time, so 25t. So you've got a triangle that's growing over time. One side of the triangle is 25t. The other side of the triangle is 20 minus 20t. And I want to know at what point of t is that distance the greatest or the least? When are they closest together? So writing my formula for that, Pythagoras theorem says that d squared is 25t squared plus 20 minus 20t squared. And taking the derivative of that. Now I would just take the derivative of all three steps at once and do chain rule here and use implicit differentiation. But in case you haven't done implicit differentiation yet, I'm going to solve this for d. So to get rid of the square, we'll take the square root of both sides. That makes this derivative much more difficult. If you were to take the derivative of d squared and write it 2d times d prime, and maybe try and treat it that way, see if you could make some headway with it. That might be a way to try it. But we're going to stick with well, the speed we see here. So taking the derivative, which would be the d by dt for that distance, or d prime, you are going to, again, this is just 25t squared and 20 minus 20t squared, and the whole thing is square rooted, so that means it's to the 1/2 power. So to do my derivative, you're going to get 1/2, keep the bracket the same, 20 minus 20t squared to the minus 1/2, then times the derivative of what's in the bracket, which is 2 onto 25t to the 1 times 25, plus 2 onto 20 minus 20t to the 1 times negative 20. So my d prime is this whole part here is the numerator divided by, because it's a negative exponent, divided by this radical, and there's a 2 in the bottom. Okay, so my denominator is a 2, radical 25t squared, 20 minus 20t squared. Up top you have that 1, and then you've got what was in brackets here. Well, 2 times 25 is 50. 50 times 25 gives you 1250. So I have 1250 t, and then I'm going to have a negative 20, and 2 makes negative 40. So minus 40 onto 20 minus 20t. Now, I'm not too worried about how messy that denominator is, because when you set this equal to 0, we're not too worried about the denominator. It's never going to make it 0. So we're just focusing on the numerator here. So now I'm down to 0 equals 1250t minus the 40 goes on the 20 and the negative 20, so minus 800, then plus 800t. Take this 800 over, and you get 800 equals 1250, and 800 makes 2050t. We're going to have to reduce this. So t is 800, I don't know why I wrote 8,000, 800 over 2050t. So we'll reduce the fraction, and you a very nice 16 over 41. So that is the time that in hours that you have to, or when that the boats travel when they are their closest. So at 16/41 of an hour past noon is when they are closest. So whatever 41ths of an hour is, 16/41 of an hour, at that time past noon is when they would be at their closest. Let's look at the last example. We're over 20 minutes in this video. That's a record for me. A 1 kilometer racetrack is to be built. It'll have 2 semicircular sections, so semicircular section at each end. Those are half a circle. And you've got a rectangle in the middle. What is the dimensions of the track that will enclose a maximum area? And it's a 1 kilometer racetrack, so the distance all the way around is 1,000 meters. Okay, so since you've got a circular section here and a circular section there, and that R you could label as an X here and here. So you know the radius of the circle. The 2 semicircular halves makes for an entire circle. So you really get the area of a circle, which is pi x squared. And you have the area of this rectangular section, which is 2x times whatever this length will be. Let's call it y. So you have a 2xy and you have a pi x squared. We want to have a maximum area. So that total area of pi x squared plus 2xy is what we're going to maximize. So we'll take the derivative of that, set it equal to 0, and solve. However, we don't want to take the derivative when we have 2 variables, so we need to look at the other piece of information given. The 1,000 meters is the perimeter. The perimeter of this is the perimeter of both semicircles, which means a circle, which would be 2 pi times the radius. So 2 pi r is the circumference of the circular edges, and then you have those 2 y sections in there that are part of that perimeter, and that equals 1,000 meters. So if there's a factor of 2 everywhere, I think pi x plus y would equal 500. We will solve this for y. You get 500 minus pi x. That, like each of the other questions we've done before, is going to get substituted right in there where you see y. So I now have an area formula that says pi x squared plus 2x onto 500 minus pi x. Now there's only x's, so you're going to be good to take your derivative. We'll do some simplifications first before I take my derivative. Pi x squared plus 1,000x minus 2 pi x squared. These are the same term, pi x squared and 2 pi x squared, so we will subtract those. I'll still have my 1,000x, and 1 pi x squared minus 2 pi x squared is just minus pi x squared. Much easier function. Taking the derivative of that, I get 1,000 minus 2 pi x. Set it equal to 0. Okay, set variables to one side. So 1,000 equals 2 pi x. X is equal to 1,000 over 2 pi, which is 500 over pi. That is the part that will give you the biggest area. If you were thinking of this section, then what is happening is you've got those two semicircular sections. If the radius, if this x is going to be 500 over pi, and then the circumference is going to be, we said, 2 pi times r. 500 over pi, and look at what happens. You're left with 1,000 meters. It turns out if you want to maximize that, you want this section of y to be 0, and you want to just have a circular area. Any shrinking on the radius of the circle and extension of the straight sections of the track actually make the area worse. It turns out that having it as a complete circle is the maximum area for this question. The other way to figure that out, of course, is when you go to plug in y. We found out just up here that y was equal to 500 minus pi over x squared. When you go to plug that in, minus pi, not x squared, but x, I mean, you plug in the x of 500 over pi, and it comes out to 0 pretty quickly here. The pi's cancel, you get 500 minus 500 equals 0. And you come to the realization that the best shape there is a circle, not an oval track. Okay, so there are a number of examples, almost a half-hour video of pure calculus fun for you. Congratulations if you made it this far, and I hope that helped you out.